Right, good morning. So today we're looking at the Leadership College TLC paper 2. Let's check here. The Leadership College paper 2. At this point we have dealt with question 1, question 2 and the whole of question 3. Is that correct? Did I start question 4 already with you guys? No. Okay. So what happened was in the previous video I was cut for some reason or other. So you'll see there's a disjoint there. So what I did was I made another video. There was parts of the question that is overlapping question 2. That is in the next video. Okay. So I started question 2 all from over again. So that, with pleasure, so that we can have a continuity through the video itself. Okay. So that said, let's just take this off here. Now we're on question 4. Okay. So the question says in triangle ABC. Angle C is 90. Okay, very lightly. It's 90. Determine AC. How are you going to calculate AC? Opposite that? Adjacent, which is? 10. So tan of 62, 1.2 equals AC over 23.8. You all okay with that? So what do I do now? Cross multiply. So AC is equal to 23.8 tan 61.2. Then the calculator. Okay, the calculator is acting up again. So I'm just going to get to sort this out. Sorry about this. Come inside. Hi there, how are you doing? Sorry? Right, so okay. So in other words, we have 23.8. Then make sure there's a D on top for degrees. 23.8 tan of 61.2. That gives us 43.3. You all okay with that? No? Yes. 43.3. Okay, they didn't say for how many decimal places, so I'm just going to go with 2 decimal places. You all okay with that? Right, let's look at the next one. In question 4.2, 1.2, the question says calculate AB. So we're looking at AB. Pull this down a bit. So AC was 43.29. Okay. To calculate AB, how can I calculate AB? Pythagoras. Or I could have used sine or cos. Not so. But Pythagoras, so it's 8b squared is equal to AC, which is 43.29 squared plus 23.8 squared. The reason here would have been Pythagoras with the angle C being 90. But since this is it is not Euclidean geometry, so I don't need to give a reason. Okay? But if you write the angle C is 90 for Pythagoras, that's better for you. Okay? So we say answer squared plus 23.8 squared. The square root thereof gives us 49,4. You all okay with that?
Yes.
AB is 49,4. Okay. And then they ask you to calculate angle A. It's simple. How do you calculate angle A? It's going to be 180 minus 61,2 minus 90. It gives you 28,8 degrees. Okay, any confusion there? No? No. Let's go for 4.2. In question 4.2 we are told a wall AD is 9,3 meters high. B and C are 2 points in the same horizontal plane, so we assume that's the ground, as D. The angle of elevation from B and C of A, no, the angle of elevation from B and C of A are 23 and 48,2 respectively. So it means to say in that order. Okay. The question says determine the distance between B and C. I'm going to calculate this distance between B and C. First find BD, yes? And then you calculate CD, yes? You subtract the 2 and you'll get that. Not so? Because this here does not fall within a right angle triangle. Does it make sense? It doesn't fall in a right angle triangle. So I can't use sine, cos and tan as I normally do. Sine, cos and tan only works in right angle triangles. Make sense? Right, so let's go with that. So we're going to work, you don't have to say this, but I am just going to say it for reference purposes. In triangle ABD, which is a big triangle here. Okay? In triangle ABD. So that's my angle. That is opposite, and this is adjacent. That's what I'm calculating. Not so. If you can't see past that, no problem. Redraw it. 7.3. This is BD. 8. This is 22.3. It didn't go. Opposite and adjacent is still 10. Did you see that, people? Right? I'm sure most of you, or all of you, can see past that. So it's going to be tan of 22,3 degrees equals 7,3 over BD. So what do I do now? Cross multiply. Okay? So BD, tan 22,3 is equal to 7,3. Then you divide both sides by tan 22,3. So that's going to give you 7,3 over tan 22.3. Okay, you all okay with that? That gives us an answer of. It would be nice if somebody give the answer. 7.3 over tan 22.3. The 17,3. No. 17,8. Okay, that didn't say to 2 decimal places or 1, so I'm going to say yes, still in any case 17,8. 17,8 meters. So this length here is 17.8. You all okay with that? Right, let's look at in the other triangle. In triangle, in that triangle we're going to calculate CD. Not so. So which trigonometric function uses opposite and adjacent? Tan. So we say tan 48.2 is equal to opposite 7,3 over CD. So what do I do now? Cross multiply. So CD tan 48,2 equals 7,3. How do we get the CD on its own? Divide by tan 48.2. Put that in the calculator. 48.2, 6.53. Not so? 6,53. Did I ever answer the question? So therefore, in conclusion, BC or CB is equal to 17,8 minus 6,53. Which then gives us, so it's 17.8 minus that last answer calculated, 11,27. Meters. Okay, any confusion here, people? Right. Then the next question, so dependent on this, yes. The angle of depression. People, if you guys are depressed, please speak to our counselor, okay? Don't come to me now, I'm going to cry with you. What do you say? What did you say? No, say what you said. I'm waiting, my girl. What did you say, Kelsey?
No.
I'm waiting. I'm wasting my time.
I would assume so. No.
Not cry.
I don't say. I wouldn't. I don't think so. Cry. That's what I said. No, that's not what I said.
Do you think I have no feelings?
No, so I should just be giving on the show.
How much I know? Oh, you're making jokes in the maths? Oh, okay. Making jokes in the maths course. Nice. I like it. Yeah, we've been trying to be serious and we building careers for micronation and stuff like that. And you're making jokes on the side? But anyway, we are told that the angle of depression of B from A. So the angle of depression here is referencing this angle here. Can you see that? Depression is the angle that goes down with the horizontal. And the angle of elevation is the angle that goes up with the horizontal. You see that? This here will definitely be parallel to that side. Can you see that? So what is the angle of depression? The angle of depression is definitely 22, 3 degrees. If it was the angle of depression of C from A, then what would it then have been? It would have been this angle in question there now. So there is C. Can you see that? It would have been 48,2 degrees. But the reference angle is B. So it's in 22, 3 degrees. And what is the reason that it is on? Turn at the angles. Make sense? Right. People in question 4.3. I'm going to pause here quickly and then I'm going to draw the quadrant. I'm going to draw the graph quickly, okay? Alright, so in question 4.3, In question 4.3 we are told given f of x equal to cos x plus 1. So what's happening to the cos of x graph? Shifted 1 unit up. And g of x is equal to 2x. So what's the variation, what effect does the 2 have on this graph? The amplitude, stretch. Not so. Horizontally by a factor of 2. No? And sorry, vertically, not horizontally. Vertically. That is your horizontal effect, okay? So the cos x graph, we know that cos x does this here, start on top. That is 1n minus 1 and 360. Not so. Shifting 1 unit up, 1 goes to 2. This is 90. Goes 1 unit up. This is negative 180 and 0. 180 and negative 1. 180 and 0. There's that one and that one there. You all okay with that? Yes. Alright. So I do what I do best. Connect the dots. They tell you something about somebody and then you write a book on that story. No? So it's 360 and 2. That point is on there and that point is on there. Not so on the axis, so I don't need to write the coordinates here. Okay? And there, since there are two graphs on the system of axis, I call that F. Alright? If there is more than one graph on the system of axis, you must label the graphs. Okay? If you're looking at the g of x graph, the basic sine graph does this. This is sine x. Okay? That is 1 and minus 1. That's 360. So what happens to this graph because of that 2? It is enlarged by a factor of 2. Okay, or stretched by a factor of 2. So 0 stays 0. Okay? 90 and 1 becomes 90 and 2. Not so. 180 is 180 and 0. 270 is normally 270 and minus 1. So in this case, it's 270 and minus 2. And then, of course, it ends up again at 360. So there's that graph. And this is the graph of G. Right, you guys understand? Alright. Let's carry on. What's the next question? It says draw a neat sketch of the graph of G and F of 0. You see when it says 0 to 360, you must start at 0 and end at 360 degrees there. So in the next question they ask us, in 4 point, I'm going to put here 4.3.2, use your graph to determine for which values of x is f of x equal to g of x. So we have two graphs equal to each other when they overlap, when they intersect. Not so. So they're overlapping here. Okay? Which looks like it's at which point here? Midway, so it's 45 degrees. Not so. Where else are they equal? At that point here. Okay, my drawing is not that good. Both is going through 180. So x is equal to 45. 180 and where else? That's it. Not so. It might intersect. It will definitely intersect as this graph carries on. Not so. But from the graph you can see that those are the 2 points. Yes, you. Cover?
So it doesn't intersect at 45 degrees because if you plug in 45 into the equations, then cos plus 1, then it gets.
You are absolutely correct. Yes, right. So the only point we can actually say is this one. What she's trying to say is that if you put 45 degrees into the equation, which is 2 sine, I think the one was 2 sine x, no? It's going to give you root 2. The other one is going to be root 2 over 2 plus 1, I think. The other one is going to be cos 45 plus 1. Yeah. Which is 1,070, and the root 2 is not that. Okay. Which means to say, no, that's not right. 1,707, and the other one is 1, as you can see, is not the case. Okay. So you are right by saying that it can't be 45. However, this is another point here, whatever point A is. Okay. In the memo, what did we say in the memo it was? Sorry? 180. Okay, so that is the only point you could have actually do. Yes?
But is there a way to like figure out?
Yeah, definitely. Absolutely. That's what the grade 11 grade 11 3. Okay. Right, next question. But thank you for highlighting that. So did you thought of that argument before you saw the answers? Is it?
I'm trying to like make the two.
Sorry? We're trying to set the two graphs equal to each other.
Yeah, but then I have to find something.
Yes. Right, let's look at the next one. You say, what's the period of f? What's the period of a graph? Time taken to complete one full cycle. Okay, which is 360 on both graphs here. Okay. What's the period of the tan graph? 180. So the period of the f is 360. Yes, the girl that makes jokes in the class? Yes?
Oh, so
Yes?
they were both graphs touch each other. Doesn't it mean that's where they
Intersect, yes? We are they equal, yes?
yes. But going back to 4.3.2.
Yes? I'm listening.
Is it just x equal to 180 or is there another one?
As I said, if you had listened to me, I said earlier on that this here, this point A, should have also been a solution. But because this, you at this level you can't calculate, if you say the two graphs equal to each other, and you do the calculation to work out for that point of intersection, you actually need grade 11 knowledge on three general solution to answer this question. So this is actually out of your syllabus for you to have actually have answered this point. But it's actually intersecting there and there. But if you look at the memo only have one equal. Yeah. And the reason for that is because this is the point that you can read off from your graph at this point. So if you have written in your answer a value here, that's going to be a value close to giving those answers, then you won't be penalized. Because it's going to be unfair of us to penalize you here for writing, for argument's sake, 45. But if you haven't written 180, then by all means, you're not going to get them all. Makes sense? Alright. People in question 4.3.4, what's the range of y? What is g, sorry. What is the range? Range in all is all possible? Y values. Not so. So if you're looking at the graph of g is this graph. So it's going from there till there. Not so. So if you take that into account, it's going from -2 to +2. Can you see that, people? Is that correct? Yes? Take this purple look here. Where's it taking it away? So your range is y is greater than or equal to -2, but less than or equal to 2. Of course, there's another way of writing it. You could have written it in set boulder notation. Not set boulder, interval notation. Does anybody use interval notation here? What is that? That way you write block. So y is an element of block -2 to not a O, it's a y, no? Right. So that's the way you write in interval notation. Okay. Then the last question it says, let's change our color again, we haven't used green. We say here, for which values of x is g of x decreasing? So g is this graph in blue, not so. Is this graph increasing or decreasing here? It's increasing. As x increases, the value of g or the graph of g is increasing. You want to know it's decreasing. This part here is decreasing. Decreasing till which point? Till 270. Then it starts increasing again. Not so? So it's decreasing from x equal to 90 to x is equal to 270. So for which values of x is g of x decreasing? It's decreasing for x is greater than 90 degrees but less than 270 degrees. Okay, any confusion there? No. All okay?
Yes,
Right. Let's look at question 5. We're going to run out of space here. In question 5, the question says calculate the value of x in each of the following questions. How many marks on the sum? 5. Okay. So the marks basically tells you how much work goes into it. Most of the time. Yeah? Sometimes it's not as simple as that. But yeah. So how do we calculate x here? We need many things, not so. To calculate x I need e, which I can calculate from a, and I need c2. Not so? Then I can work sum of triangles. C2 I can work out once I got C1 and this angle and that angle of course the same. Not so? Then I can go with the angles on it straight. Okay? So you lay it out so that it makes life a bit easier. Instead of you calculating all the angles, we just calculate what is needed. So what do I need? I definitely need that one, and that one. Okay. So what can be calculated first? E could be calculated first, yes, absolutely. So E, just move this up a bit. So E is going to be 180 minus 130. Reason? Co-interior. The U is being used there. So it's co-interior angles with AB being parallel to ED, which gives me an answer of 50 degrees. Read that one so. I'm going to calculate C1. You see C1 is the same as ABC, this angle here. Why? Angles opposite equal sides. Never say isosceles, no? The swear word first. Okay, isosceles, you're going to lose a mark. You think it's something wrong with you. No? You're going to use either angles opposite equal sides, or sides opposite equal angles, depending what is asked, or which other theorems you use. So we're going to say firstly that C1 is equal to ABC, or CBA. Could I have just said angle B? No. Why? More than one angle at angle B. You see there's that one, and that one. Not so? It's more than one angle at angle B. However, here there's only one angle at E, that's why it's a CD. Why is that the case? Because that's angles opposite equal sides. Not so? So now I can say that 130 degrees plus angle C1 plus this angle, which is the same as angle C1, not so? There's 2C1 equals, these three angles add up to what, people? 180. Why? Sum of triangles. In this triangle A, B, C. You don't have to say the triangle you're working with, but it's just nice to follow through with that. Okay, you won't be penalized if you leave it out. You won't be awarded extra marks if you put it in. Yes, Michael, what's the question? Sorry? Nothing. Now why are you giving us signs? Sorry? Say? It's nothing. You're just showing us signs. And she looked terrified. Are you okay, Michael? You're not threatening you with anything. Huh? No. So we take this over. 180 minus 30 gives you an angle of 50. 50 divided by 2 is 25 degrees. So in other words, that is 25 and this is 25. Okay? This is that angle ABC is 25. But we don't need it, so I don't like it. You all okay with that? Now what do we do? Now what? Angles on a straight line. Or I could have said exterior angle is equal to sum of two interior offset. That could also work, no? But since we saw the angles in a straight line first, so let's use that. So it's going to be C2. Angle C2 is equal to 180 minus 25 degrees minus 85 degrees. What is that size thing? Angles on a straight line. Work out that in an angle of? Yes? There's 95, 75, 70. Yes. Okay. 70 degrees there. So now we're going to calculate x, sum of triangles, or angles in the triangle. You all agree with that? So you're going to say x plus 70 plus 50 equals 180. Sum of triangles, it is triangle. The CED. Okay. So x equal to that, of course, is 120. You 60 degrees. Okay. So that's the first one. In number 2, oops. In 5.1.2, again to solve for x here. Move this down. 5.1.2. So what do we do here? I'm going to calculate x here. To calculate x, I need this angle here, not so. Then I can go with sum of triangles. Or if I got that triangle, sum of triangles. Not so? Okay? How many marks are the sum? 3. 5 marks. I almost want to say it's a rhombus, but we must prove it's a rhombus first. Okay? Otherwise, yes? Yes, there's a parallelogram here.
And then the LV is the side minus LV.
Yes?
We need to say that and then do it like this.
Yes, now I don't want to say that, I know that. No? I'm looking for a quicker way. Because what I said was, you need to prove it's a rhombus for the approach I'm seeing already. Okay? But I don't want to do that. I want to see there's another way. You understand? don't see anything else. Kelsey, you see anything else? Other than a rhombus, going the rhombus route. You also went to the rhombus. Oh my word, you're still making jokes. Okay, so let's go with that. So since we say, we can firstly, it's not given a parallelogram. Okay, so we have to first say it's a parallelogram. So we will say, since, just give me a minute. Since AD is parallel to BC, that was given, and AB is parallel to DC, that's also given. Therefore, ADCB is a parallelogram. So now the properties of parallelogram is 4. Okay? Two pairs of opposite sides are parallel. Two pairs of opposite sides are equal. Opposite angles are equal. And the angles bisect each other. Okay? So if this is a parallelogram, that means to say that is equal and that is equal. Okay? So it was the parallelogram. But we are given, now we conclude since, it's given that AD is equal to AB. That was given equal. Therefore, ADCB is a rhombus. Why is it a rhombus? All sides are equal. Okay, now we can use the fact that it's a parallel rhombus. Okay. So now, both sides are equal. At this point, we have proven it. Now, there's a property of a rhombus. The rhombus property is 5. No? Properties of a rhombus is 5. The one property we need to use here, and the time is running out here, is that your diagonal bisects your vertex angle. Okay, that's the property of a rhombus thing that we will be using. So we say that A1 is equal to 2x. Why? Because the diagonals of a rhombus bisect the vertex angle. Alright, so that is 2x. So what do we see here now? Coming theta angles. You see that? So we say 2x plus x, which is 4x you could have said, plus 68 is equal to 180. Why? Going theta angles with AD being parallel to BC. So that's going to give you 4x. What's 180 minus 68? Sorry? 112 divided by 4? Alright. Yes, what method you were talking about?
Oh, I did the first, with the old side.
Yeah?
And then I took the 68 to the other side.
You take the 68 to angle D.
Yes.
Yes?
That's how I did it.
But now you're going to say angle D 68 and then what did you do?
And then yeah. And then I said leg. Since A1 equals to C because of angles opposite equal sides.
Angles opposite equal sides.
Yes.
Oh, so you went and proved this first?
Yes.
Oh, I thought you were using something other than a rhombus. So I was thinking, isn't there another method we could have applied other than using the fact that it's a rhombus? No. We also use the rhombus. Okay, no problem. 5.2. In question 5.2, we are told that ABCD, so we need to we are told that ABCD is a parallelogram. So A BCD is a parallelogram. So, 4 properties come to mind. Opposite sides are parallel, which we already can see. Opposite sides are equal. Opposite angles are equal. And the angles bisect each other. Okay? Just by saying that, all of that is a given at this point. Okay? Then we tell that CR bisect angle DCE. DCE. CR. Which means to say that that angle is equal to that angle. Not so? And we are told that CR is parallel to DC. Which means to say those angles are equal. So that will also have that marking here. Not so? And there's also alternate angles here. So that will also give that marking here. You see that? These lines are parallel here. So that will get 2 markings. And so on and so on. No? There's more angles that are equal to those angles I've marked at that point. You all agree with that? Right, let's just take the color off here. I'm just going to keep 2 dots at this point here to remind me that those 2 are equal. Very importantly, in your exam, you will get an answer book. Okay? You write on the diagram in your answer book, so that if you had made a mistake, it's easy for the examiner, or even if you had made no mistake, it's easy for the person who marks your work, the marker, to follow your reasoning. Okay? So you know in geometry, there's many ways of doing things. Not so. Not everybody's going to apply the same method. Alright. So let's go with 5.2.1. In 5.2.1 it says prove that triangle BDC is an isosceles triangle. So when we prove triangles are isosceles, we have to prove one of 2 things. We either prove that equal, 2 angles are equal, or 2 sides are equal. One of the 2. You guys understand? Go for it. Look here. The one that's looking at the back. Right. The one looking forward. Yes. Yeah. Okay. People, so what happens? As I said, we're going to either prove that 2 angles are equal, or 2 sides are equal. Okay. So they also said let DBC equal x. Okay. Let DBC equal x. So which other angle can we now say is equal to x? Oh, earlier on I said this is 2x, no? Or 2 dots, I made a mistake. It's 1, it's with that angle. Okay, so I will complete this video. I'll post it in the group. Let's just give you a homework before I forget. So I will conclude this video now. No? Alright, so as promised, let's just wrap this up. So if this is x, and to prove this is an isosceles triangle, we have to prove that this is x. Okay. So of course you won't be able to go straight into concluding that it's x. So of course the corresponding angles are equal. So this angle and that angle is equal, so C2 will be equal to x, corresponding angles. Okay. So angle C2 is equal to x. Corresponding angles, with RC being parallel to DB. But we know that this angle there is equal to that angle because of the fact that it's alternate. However, angle C1 is equal to x. Why? Because it's given that CR bisects DCE. Okay, so there's an x as well. So of course now BD C is equal to x. Why? Because it's alternate angles with BD being parallel to CR. Okay. So what do you see now? That those angles are equal. So we say, since, state the obvious, since BDC is equal to DBC, which is this angle, which is equal to x. Therefore, triangle BDC is an isosceles triangle. Why? Because its angles, base angles equal. Or you can say angles opposite, it's not equal sides. You can say two angles are equal, or base angles are equal. Okay? So now we can use the fact that it's an isosceles triangle now in the next calculation. However, if you didn't prove that this was an isosceles triangle in this case, okay, you can use it in the next diagram, in your next question, because the one question normally leads into the other. Okay, so if you didn't, again, prove that in 5.2.1 is an isosceles triangle, you can use it, the fact that it is an isosceles triangle in the next side. Okay, so I'm going to take it off here. You can have space to keep the diagram in focus. Okay, but we filled in now the fact that it's an isosceles triangle. Let's delete that. So any question? 5.2.2, we are asked to prove that ABCD is a rhombus. Okay, I think I wrote this too early. So, for it to be a rhombus, all sides must be equal, or with diagonal must bisect the vertex angles. Okay. So I'm going to go with this fact that the sides are equal. Okay. Remember, this is a parallelogram given you. So already at this point, those angles are equal. Oh, sorry, those lengths are equal. However, since these angles are equal here, those sides must also be equal. Why? So it's an isosceles triangle. Sides opposite equal angles. So if this is equal, then all of these are going to be equal here. Okay? Alright, so let's go with that. Let's just put this back here quickly. So, as I was saying, that since those sides are equal, opposite sides are equal, so all the sides will be equal here. So I wasn't now lay it out properly. Okay. So ABCD is a rhombus. So we say since DBC is equal to BDC. Okay, that was proven. Okay, therefore DC is equal to BC. Why? Because its sides opposite equal angles. Sides opposite equal angles. Alright. But we know that DC is equal to AB. Okay? And we know on the same account that AD is equal to BC. Why? Because opposite or two pairs of opposite sides, two pairs of opposite sides equal in a parallelogram. So now you see all four sides are equal. So therefore, quad ADCE or ABCD is a rhombus. Why? Because all sides equal in a rhombus. Okay. In two shapes that is the case. Okay. Is the case in a rhombus and a square. Okay, but at least it can be at this point. It's a rhombus. Okay. Again, I'm going to take this off here, so as we can keep the diagram again in focus. So if you need to, you can pause the video at this point. Okay, let's look at the last question. In question 5.2.3, we are told that, let's use a different color, we use blue. BD is 24. BD is 24. And AC is 10. Then AB is 30. AB is 30. Read again if. I think it's a proof question. Let me just check it. I think it's a proof that question. Just make sure. Otherwise it doesn't make sense. This is 20, not 20. It's TLC 2016. Yes, prove that question. Okay. So the question reads, prove that DB. Prove that DB, and prove that if DB is 24, AC is 10, then AB. So in other words, we must prove this part. So again, in our calculation, we're not going to use the fact that AB is 13. We must, in conclusion, come to AB to be 13. However, since the diagonals in a rhombus is perpendicular, I can use Pythagoras. But since whatever is not on the diagram, I must state it. Okay, so we're going to firstly say that AOB is equal to 90 degrees. There are three such shapes where diagonals are perpendicular, one being the rhombus, square, and a kite. Okay, so that's 90 degrees. Why? Because ADCB is a rhombus. Again, if you didn't prove in a previous calculation that was a rhombus, I can use that in the fact that it was mentioned before in this question. Okay. Then we know that AO is equal to half of 24, which is 12, and BO is half of, no, not that. That's going to be 16. That's going to be 16. AC. AC is 10, not 16. So AO is going to be 5. Okay? And BD is 24. So OB is 12 centimeters. Why? On both accounts is the same. The reason is diagonals bisect each other. In this case, you could say it's a parallelogram or a rhombus. Diagonals, because the first shape was given as a parallelogram. Again, you could have said either diagonals of a rhombus or diagonals of a parallelogram. Okay. So we now say, therefore, in the theorem of Pythagoras, AB squared is equal to 12 squared plus 5 squared. The reason then, we need the reason why, because I was busy with Euclidean geometry. Pythagoras with AOB equals 90 degrees. Okay. You can leave the Pythagoras part out, but that, if you leave this part out, you will lose the mark. Okay, you lose the mark. So AB squared is equal to 169, and the square root of that, therefore AB is equal to 13. And then we have just proven that AB is 13. Alright. I think that is easy enough. Okay. So that basically brings us to the end of the TLC November 2016. Alright. These videos are free.